Alright, so in the last video we plotted a sink, and a sink is a characterization of the equilibrium solution, which is the origin, at which all solutions are heading towards it. And so now we want to take a look at a different type of behavior. And so, excuse me. Okay, so we're going to try a little bit different behavior here. So in this case we have c1 e to the minus t times 1 1 plus c2 e to the positive t minus 1 1. Yeah, I'm just kind of making this one up because I wanted to make sure my eigenvectors are nicely separated so we can actually see what's happening pretty well. And so how do you start? Well, you take a look at each of the eigenvectors separately. And so 1 1 would go along. I'll just go ahead and draw the line for 1 1. Okay, 1 1. And then the line for minus 1 1. Okay. That didn't work very good. Okay. That's pretty good though. Oop. That's not a good line. Okay. Now, for e to the minus t, we know that any solution that starts on this line will head towards the origin. And similarly, down here, that would be where c1 was negative. All our solutions would increase to the origin. So we know along this line, everything goes towards the origin. Good. Similarly, along this line, the line for negative 1 1, any solution that starts there is going to go away from the origin, and not just in any direction, but along this line, right? Good. And now we can ask, well, what happens to points that are off both vectors, or both lines, I should say? Well, if we look at our two expressions here, e to the minus t, this part of the expression is going to 0, and this part is going to infinity. And so we're going to be going to infinity then if c2 is not equal to 0, and it's going to be along this vector. Okay, so what's going to happen is that initially you may be going along this way, but then pretty soon things are going to catch up and you'll be heading towards, or you'll be becoming unbounded along the vector minus 1 1. Oops, they don't intersect each other. Okay, and so this kind of the origin in this case, the origin in this case is called a saddle. And I'd like for you to think about what all the behavior is for a saddle. And it comes from our expression up here, because every one of these solutions goes to infinity except for, do you see which ones don't go to infinity? Yeah, it's these. These are the only ones that don't go to infinity. They go to 0. So the pink ones go to 0. Everything else goes to infinity. I should say unbounded. They become unbounded. Plus or minus infinity. Okay? And so that is the description of a saddle, is that all solutions go to infinity except for 2. Unless you're starting on the... yeah, by the way, just for a little vocabulary, this pink line here is called the stable manifold, and the other eigenvector, this green one, is called an unstable manifold. And so you might hear people using those terms. I'll try not to, but I don't like to use terms that you may not be familiar with. But okay, so let's try one more. So now we have sinks and saddles. The last one we talked about in class was the source. We just barely had time for it. c1 e to the t 1 1 plus c2 e to the 2t negative 1 1, and in this case you'll see, right, that both of the eigenvalues are actually positive. Okay, And so if we draw our graph, yeah, almost did it that time. Okay, so I'm just now before we start, I want to mention something. If we go in reverse time, right, I would be going from 0 to minus infinity, and so t is going from positive to negative, and so we would be looking at e to the minus t and e to the minus 2t instead of e to the t and e to the positive 2t. And in this case, we had a sink. And in the sink, we knew that because this one went to 0 faster, that things would go towards the origin in a way that would be tangent to the eigenvector corresponding to this 1, 1 in this case. Okay, and so the same thing, I'm going to draw the same curves here. So here I had curves tangent coming in. I'll just draw 4. And those, so if time was running in reverse, we would be heading towards the origin in this case. But now we'll switch time. Time is now going in the opposite direction. So instead of being a sink, all solutions are moving away. And this is now a source. Okay, so to draw a source, what you want to do first is think of it in reverse time and draw it as if it were a sink, but don't draw any arrows. And then once you have a few curves here that it's representative of your solutions, then just go ahead and reverse the arrowheads of how it would look if it was a sink. Good. So we made it through all 3 videos now. This is where we ended in class. What are we going to do next time in class? I think we'll be talking about complex numbers. Good. So I'm not sure if I don't think I assigned any homework for last time. So I will just post these videos for Monday or for Friday, and then yeah, I'll put the homework that includes a few sketches of solutions on Monday's homework. Okay, see you later.